In this video, I'm going to be comparing the volume of cylinders and the volume of cones. And to do that, I've constructed some little examples that I will show to you. In this one right here, I have this cylinder filled with popcorn kernels, and it's clear, so it's difficult to see, but I have a cone right next to it. And I tried to make this so the height of the cone was exactly the same as the height of the cylinder. And I also tried to make it so the size of this circle on the top of the cone is the exact same size of the circle here on the cylinder. So the first question I have is, which one is bigger? Which one holds more volume? And so to do that, we are going to begin by pouring the popcorn kernels from the cylinder into the cone to see if we can completely fill the cone. So let's go ahead and begin filling that and see what we get. And it looks like now we have completely filled the cone, and there is a lot of popcorn left in the cylinder. So it's not a surprise then that the cylinder has a greater volume than the cone. And remember, this is true when the circle is the same size as the circle on the cylinder and the height of the cone is the same as the height of the cylinder. Next, we've got this one filled up, but the next question is, well, how much bigger is the volume of the cylinder than the volume of the cone? And we can keep this cone right over here, but let's bring in a second cone and let's start to fill this one. Alright, it looks like now we have completely filled a second cone and there is still popcorn left in the cylinder. Let's bring over a third cone. Let's fill up this one. And we have now filled the third cone. Let's bring all those cones over here next to the cylinder. We have filled up 3 cones, and now this cylinder is completely empty. So it's kind of interesting to me, kind of a coincidence, that the volume of this cylinder will fill exactly 3 cones, not 2.5, not 4.5, not 5.5. Exactly 3 cones can be filled from that one cylinder. So now the next question is, what are we going to do about our formula? So, if we are looking at our formula for the volume of a cylinder, our formula for that was pi times the radius squared times the height of that cylinder. So that is our formula for the volume of a cylinder. Well, what are we going to do to the formula for the volume of the cone then? If that's the formula for the cylinder, how many cones could we fill? We could fill 3 cones, so each one was holding a third of the volume of that cylinder. So now, our volume of the cone then is 1/3 of the previous formula, or 1/3 times pi times the radius squared times the height. So that's where you can get that formula for the volume of a cone from the volume of a cylinder. Thank you to my student volunteers.
Wait, point your whole class in now.
Okay.
Okay,
Yes. Yes, there's my whole class.
Hi.
All right.